It's time for the next installment of Make Electronics, where I go through all the different experiments in this book and its successor, Make More Electronics. So we're now to experiment 6. Which is called Getting Connected. But there is, for lack of a better term, an intermission, where the book kind of goes over what kind of tools and equipment and stuff you might need for this next section, section 2. Feel like we're moving into a new era. So I figured, let's go over this stuff, kind of the stuff that I have, and just to give you guys some information, and of course there'll be affiliate links because I like making money. You need some miniature screwdrivers, so I like this electronics focused set. There's also a bag of electronics, like a static wrist thing and stuff like that. So this is very nice. It talks about various cutters and pliers and stuff like that. So start off, I have this I forget what they call it, flesh cutters. Don't leave home without it. You can find cheap ones you can buy 5 for under $10 on Amazon. Plus, I have this Coin Tools just wire stripper. Your generic, everyday quality wire stripper. Okay, now there's a bunch of other things. What I suggest finding is a jeweler's assorted toolkit. So this is a bunch of different pliers. You got your long ones, you got your bent ones, and so on and so forth. I think this is a very good proposition for the price, and you get, you can find kits with 6, 7, 8, and so on and so forth. Okay, now, breadboards. Obviously, the book talks about these two, and there's also one with single rails on each side. One's positive, one's negative. All mine are dual. And as you've seen, this is the one I use for a lot of the experiments so far, and it keeps everything organized, and I can plug things in and stuff like that. So, there you go. Now, hookup wire. There you go. 22 gauge, solid core, hookup wire. Works perfect. Now, there are 2 other kinds of wires in here. Now, I'm not using any stranded wire. I hate stranded wire when it comes to this kind of thing. Now, you have these jumpers. Now, these are pre-cut. Now, the book kind of frowns on these strictly because the color codes and everything are there's no rhyme or reason to it, to the lengths and stuff like that. If you want to have your colors matching for what kind of signal, or if it's ground or power and stuff like that, this is hard. And the lengths are what they are. But when you're doing a few things, you can't beat these. Very easy to put together. And then also you have these. These are just your, what do they call it? Flexible jumpers. If you do 1 or 2, these are great. Otherwise, this becomes a mess very quickly. But they're also extremely cheap. Okay, so there's a series of other components you might need, or are going to need. Switches. So as you can see, these are pretty small. So these are the same, just different sizes. So I'll show you something in a minute, but then there's these tactile switches, or momentary switches. These only work when you press them. Once you're done pressing them, you can hear the click. They're no longer making contact. So I got 2 little ones here. Speaking about switches, I don't know, I was feeling ambitious. And since those switches are really tiny, I made a giant switch. Kind of like the book in the experiment that we'll go over later. So, let me go over this. This is kind of like, just like the slide switches, except it doesn't slide. It pivots. Unlike a switch that you use every day that's turns on the light or your fan, and when you enter a room, this is also can be used for other things, for not just switching on and off, but switching different functions. So right now it's off. It doesn't have an off button, it's just not hooked up. So if I go one way, I now have a red LED. And if I go the other direction, I now have a blue LED. Now, the same principle happens with these slide switches. It has 3 on the bottom. So it has a common and then 2 connectors. So for the most part, you're kind of using these to on and off, but you can also do this to switch different outputs. So these are handy for doing signal control. So yeah, that's my big switch. Pretty cool. So let's turn that off. Okay, going on, we're going to need some relays. So just 2 different kinds of relays here. Different pin configurations and everything like that. We'll go over in the book, but just to show you what they look like. They're basically just boxes. Some other things we're going to need. These are just, for example, these are trim pots or trim potentiometer. These are basically adjustable resistors. So yeah, there you go. We're also going to need one of the most important inventions in human history, the transistor. So this is just a sample. Obviously, as we go forward, we'll go over exactly which ones we need, but yeah. Capacitors. Obviously, I have 2 here because the book chose to. So these are your ceramics, and these are your electrolytic. Here you go. And obviously, you're going to need resistors, but I think we've gone over those enough so far. Also, speakers. So yeah, here's your 1-inch-ish, I think it's 1 inch, 8 ohm speaker. Now, finding a 2-inch speaker, I didn't really look because it turns out I can just use this. There you go. It's just an old Sony speaker. It happens to be 8 ohms. And it's perfect. I was going to take it actually out of this and use it independently, but why? It works fine, so I can just use the connections and hooked up. So there's my 2-inch speaker. Like I said, everyone's got stuff laying around. So here's another speaker. This is only 4 ohm, so it might come in useful for something else. But yeah, so when it comes to speakers, don't hesitate to look around your house. If you're a good millennial, you'll have a box of electronics and wires that well, you just can't seem to part with. So put them to good use. And of course, we're still going to need your testing equipment, your test leads, your favorite 9-volt batteries, and your generic red LED plus your multimeter. But yeah, we'll go over that. So yeah, that's the Section 2 intermission on everything you need. Maybe I'll zoom out. So, I think it's time to get connecting. And now it's time for the feature attraction. Experiment 6, getting connected. Now, I'll be honest, this one has kind of been, well, not the most exciting one. It's a bit dull, but hey, we got to do it anyway. So basically, we're just talking about switches. As you can see, this is pretty tiny. So that's why I made the giant switch that I showed at the first half of the video. Yeah. So let's get into the book. So obviously, I've already gone through and set it up so this is a bit clearer. I'm going to zoom in. There we go. Okay, so for the first figure, that's 633. Basically, this is just a switch. So we're just going to, I have the voltmeter, or multimeter, whatever you want to call it, set up in continuity. and I have it on, it's going to make a beep, and we'll see where we go. So it's all hooked up. Now watch. I do this. It's now, I've closed the circuit. It is the loop. That's why it beeps. So then you got figure 635, which is these two switches down here. Watch. If I flip the top one down, I have continuity. If I switch the bottom one down, I broke it. Now if I switch the top one back, I still have nothing. So, and for 635, the bottom switch has to be up for it to work at all. So that is showing switches in series. Okay, so over here, this is a 638. This is a series parallel circuit. So watch what happens. If I go down, if I flip the bottom one down, oh, it's off. Now I flip the top one back up, it's on. Pretty nifty. Basically, what I just demonstrated there was the exact same thing of what a three-way switch is, which is shown on figure 642. So here, I'm going to disconnect my multimeter, and I'm going to hook a battery on now. So it's very common to find three-way switches in your kitchen or dining room, something you can turn the lights on from multiple places. So they're both up. So if I press down, it turns on. So if I leave from the other entrance and I want to turn it off, I flip it off. But if I come back from the other side and still want to turn it, I can just go on. See? So each switch can independently control the light. Unlike this combination over here, where the in series, this has to be on for this to be able to do anything, for the top one to be able to do anything. So, like I said, this one's kind of dull. So that's kind of how I made the intro with the stuff we need to do for the equipment you need for section 2 of the book. And of course, starts to go over symbols you'll see in the book and stuff like that. Doesn't make for the most interesting video, but nonetheless, it's there. It goes over through different kind of switches and everything and stuff like that. But one thing I did do, because I was kind of bored, is I did go ahead and make this. This schematic, I turned it into an actual functioning circuit. So, you can see on the diagram, it says it's looking for 6 volts. So, AA batteries are 1.5 volts. You put them in series, you got 6 volts. So, I'm going to turn these all on, and there goes our lights. So, the book doesn't actually say what this circuit is supposed to do, but the bulb lights work. So, we'll put it. We'll just say that it works. We've got 2 transistors. You got your 4 resistors, your two capacitors, your LEDs, and so on and so forth. So yeah, like I said, this one was kind of dull. If you'd like me to make a bigger video on switches and stuff like that, let me know, because I can go into it a little more detailed, but I don't want to make the videos too dry. But anyway, if you have any questions, leave them in the comments. Otherwise, stay sleepy, my friends.